Okay, we're looking at lesson 9, which is solving radicals algebraically. This is the last lesson in radicals. The key idea, which you guys see up here, which I don't have for some reason, is to eliminate the radical. Okay, and how you're going to do that is by squaring. Okay, square both sides of the equation. So we're going to square both sides. And the way to do that, of course, is we want to isolate the radical. So we'll go through a couple of examples on how you can do that. Okay, let me try a brush here. That's good better. Okay, so example one, this question actually was in your graphical example, but what we're going to do is we're going to solve it algebraically. So what I'm going to do is I'm going to square both sides. Whatever I do to one side, I do to the other. Okay, the square of square root x plus 1 is x plus 1. Okay, so this just turns into x plus 1 equaling 16. If I subtract 1 from each side, I get x equal to 15. Okay, and then we're going to do a check. I'll do my check in red. How about? So we'll do our check. So the square root of 15 plus 1. Okay, and then this is supposed to be 4 on this side. This is the square root of 16, and the square root of 16 is, of course, 4. So that worked out beautifully. Okay. What we're going to do, remember how it said isolate the radical first? Well, in this instance, that's going to come in handy. So we want to just isolate this radical. We've got to move this 3 to the other side. Okay, so I'm going to subtract 3 from each side and get the square root of x minus 1 equaling x minus 3. Okay, now I'm going to square both sides of the equation. Whatever I do to one, I do to the other. Okay, this turns into x minus 1. Okay, and this turns into x squared minus 6x plus 9. Excuse me. Okay, so I'll move the x's and the 1 over here. So I'm going to subtract the x and add a 1. Okay, subtract an x and add a 1. So I'll get 0 on this side is equal to x squared minus 7x plus 10. Okay, now this piece right here, of course, this is a quadratic, so we're going to factor that. Things that multiply to positive 10 and add to negative 7, of course, we're thinking 5 and 2. So this turns out to be x minus 5 times x minus 2 equals 0, meaning x equals 5 and x equals 2. Okay, we're going to check both of these. So 3 plus the square root of 5 minus 1 equals 5. Okay, 3 plus the square root, so this is 3 plus the square root of 4. So that's 3 plus 2, and that does equal 5. Okay, so that one works. X equals 5 works. Now let's check x equals 2. So 3 plus 2 minus 1, underneath the square root side, equals 2. So 3 plus the square root of 1 equals 2. And you'll see here that we get 3 plus 1. 3 plus 1 is 4, does not equal 2. So this does not work. Okay, so we only have one solution in this, and it is x equals 5. This is not a solution, so I'm just going to cross it out in red. Okay, let's look at this one now. The square root of x plus 2 is equal to x. Okay, well, we've isolated our radical on the left, so let's just go ahead and square both sides. Well, oops, square that side, square that side. So we have x squared equaling x plus 2. Okay, now let's group things together. I'm going to subtract x and subtract 2 from each side. So we get 0 equaling x squared minus x minus 2. Okay? Well, things that multiply to negative 2 and add to negative 1, we could do 0 equaling x minus 2, x plus 1. I think that would work. X squared minus 2x plus x would equal minus x minus 2. Yeah, that works. Okay, so we get two solutions from this. We get x equals 2 and x equals negative 1. We have to check them both now. Okay, so we have the square root of 2 plus 2 equaling 2. And of course, this turns into the square root of 4 equaling 2, which is good. And in this case, we have the square root of negative 1 plus 2 equaling negative 1. And of course, that's the square root of 1 equaling negative 1, which is not true. So we only have one solution for this. This solution is no good. So the solution that we want is x equals 2. Okay, so those extraneous roots, that's what we were looking at here. Extraneous roots is a value that does not satisfy the original question. And you can look at the key for this. I'm not going to write it out because I've just got a little mouse here. Okay, but the extraneous root in here, here's an extraneous root, okay, and here's an extraneous root. Okay, so those extraneous roots, they do not satisfy the original equation. Okay. Okay, I'm going to stop it there and we can do part 2 down here.